exactly like it sounds. Let's start with just such a problem. All right, so let's say roll a die. And let's think about this. What is the probability that we roll an even number or a number greater than 2? What is the probability we roll an even number or a number greater than 2? Well, let me write it out this way first. All right, so probability of an even or greater than 2. Use the greater than symbol there. It's going to be even or greater than 2. Now, I'll just tell you this, or, that word right there, we've talked about and, actually we talked about and a little bit in a previous chapter. And remember, and typically means what? And means what operation? Remember when we had it, it was in the counting problems, we had an and problem, and it meant, what did we do to the ones that had and? No, we multiplied. And means multiply. The basic rule of thumb is this. And means multiply. Or, in mathematics, usually means add. So I'll tell you that right up front. Now, here we have or. So, or means add. Okay? So I'm going to do probability of even plus probability greater than 2. However, I'm going to tell you also now there's a catch. It does mean add, but there is a catch. Because let's notice here something about this. If I just do the probability of even plus the probability greater than 2, I run into some problem. The probability that it's even, well, I'm talking about rolling a die, so what's the probability that it's even? Let's do it just without reducing it. There's 3 evens out of 6 total. 3 out of 6. With me on that. 3 of them are even. 2, 4, and 6 out of 6. Okay, and let's don't reduce it here, because we are going to be adding fractions, and it'll be helpful not to reduce. All right. Probability that it's greater than 2. So I'm rolling a die. So how many of them are greater than 2? 3, 4, 5, and 6. 4 of them out of 6. 4, 6. Now, I know you know about adding fractions. That's why we didn't reduce these, because now we can add these fractions. What do I get when I add these fractions? Yeah, you add the, since I've got a common denominator, I add the tops, and the denominator stays 6. 7, 6. Okay, so here's the difficulty, problem. Do you see now there is something more to it here? Why? Why is this not a legitimate answer? It's more than 1. Yeah. It's greater than 1. Probabilities cannot be greater than 1. So I can't leave that like it is. Here's the catch. What I have to do is, what happened was I counted some things more than once. Because there are some that are even and greater than 2 at the same time, aren't there? So what I'm going to do on this formula here is put minus. I'm going to subtract out basically the overlap that I counted twice. So I'm going to subtract the probability that it's both even and greater than 2. I'm going to subtract, see what I get when I subtract that. What's the probability that it's both even and greater than 2 at the same time? How many of them are even and greater than 2 at the same time? Well, 4 is even, and it's greater than 2, so that would be 1. And 6 is even and greater than 2, so that would be 2. 2 of them out of 6 are greater than, or even and greater than 2. You with me? So let's subtract 2 out of 6 off of these here. What do I get if I subtract the 2 6? 7 6 minus 2 6. 5 6? 5 6. All right. Yeah, now we're in better shape.
So why don't you do that at the beginning? Why don't you just not count it? Why do we have to?
Well, we're talking about this formula here. And this is the formula. Yeah, there's other ways of doing that one because there's, so few of a amount of them, but we do want to recognize that there is a formula. I do want you to know the formula, okay?
So we'll know if we get to a 7 over 6, anything over the 6, that we need to use that formula.
Right. Well, it's this is going to be, I'm going to write up here a generalized OR formula. Yeah. Anytime you see OR, this is the formula. Okay? So what is it? Well, here it is in general. Let me write it in general. The OR probability formula right here. If it's the probability of A or B, 2 events there, we're doing OR of them. How does it work? Well, it's the probability of A plus the probability of B, right? Because OR means add. But then you have to minus, and they usually shorten it to just say A and B. But with the understanding here, what this means, probability of A and B, it's the probability that it's both A and B at the same time. So the probability of both A and B happening at the same time. Okay? All right. So yeah, let's just do another example here. Let's say I have this one. I'm going to select a number from 1 to 10. I'm just going to pick a number, one number out of 1 through 10. Okay? What is the probability that I select what is the probability of selecting, let's say, an odd or a multiple of 3? Odd or multiple of 3. And again, let's use a little formula. So we got odd or multiple of 3. So it's going to be the probability that it's odd. We can do that. Plus the probability that it's multiple of 3. Minus the probability that it's both odd and multiple of 3 occurring at the same time. That's the way it works, okay? Just plugging in the pieces there. But it's an OR, so we're adding. We've got the little catch there, subtract that little bit. All right, so what's the probability that it's odd? Well, we've got 10 numbers. How many of them are odd? 1, 3, 5, 7, and 9. 1, 3, 5, 7, and 9. 5 out of 10. Like I said, I'm going to not reduce that in this case. Multiple of 3, how many are multiple of 3? 3, 6, and 9. So 3 out of 10. All right, what about this one? How many of them are, what's the probability that it's odd and multiple of 3 at the same time? Well, let's see. 3 is odd, and it's a multiple of 3. 9 is odd, and it's a multiple of 3. And 6 is not going to count here because it's even, right? I'm only doing the odd ones that are also multiples of 3. So that would be 3 and 9, wouldn't it? 2 out of 10? 2 out of 10. So this is what I would add and subtract. 5 out of 10 plus 3 out of 10 minus 2 out of 10. That works out to be, what does that work out to be? 6 out of 10? 6 out of 10, which is 3/5. Okay? All right. Now, one other thing let me mention we can also do is kind of like we did, there was another formula we did this with too. Let's say I've got this. And we'll come back to problems like this more in just a second. But let's say we know, let's say we know this. So if the probability of A is 0.7, probability of B is 0.36, and the probability of A and B is 0.17. What is the probability A or B? We haven't done much with the probabilities with decimals, but we talked about that, right? Probabilities can be listed as decimals just as well as fractions, can't they? Yeah. These are legitimate probabilities. So how would I do that? Well, it's a formula, isn't it? The probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. So what is the probability of A or B going to be? Well, probability of A is 0.7, probability of B is 0.36, and the probability of A and B is 0.17. So we add the 0.7 and 0.36 and subtract the 0.17. It's just plugging in the formula right there. Just knowing that formula, being able to plug that in. With me? 0.7 plus 0.36 minus 0.17, 0.89.
How come you don't turn it into a fraction?
Yeah, you don't have to turn it into a fraction. You can if you want to, but in this case I think it'd be a whole lot easier not to. Yeah, it will sometimes work probabilities with fractions. Sometimes we'll work them now with decimals. So I would just, if they give them in decimals, I would just leave them in decimals. If they're in fractions, I would leave them in fractions. If they're in decimals, I would leave them in decimals.
Sometimes we're going to have, in the P spot, we're going to have a number there. Are we going to multiply with whatever A is?
To multiply?
Mm-hmm.
Yes, we'll have some.
Okay.
We'll have another formula, yes.
Okay.
And you know, this for this formula too, you can, I mean, we could change it to where we're solving for something other than A or B. We could say do this, if, just to do another one, let's say if the probability of B is 0.21, probability A and B is 0.09, and A or B probability equals 0.43. What is probability of A then? Well, in this case, what I know, I'll just use this one from up here. In this case, I know A or B, so that would go, the probability of A or B would go over here, wouldn't it? 0.43. That's my probability of A or B. The probability of A I don't know, and the probability of B is 0.21, and probability of A and B is 0.09, so it would go behind the minus there. Yeah, this is the way these numbers would get plugged in, wouldn't they? So can I figure out A? Yeah. Just a little problem, isn't it? Let's see, these 0.21 minus 0.09 is 0.12, isn't it? Just combine these two to 0.12, and then to get A, just subtract the 0.12